For everyone who's listening to this, welcome back to class and thanks for hanging with us. We're going to continue on in chapter 9 today. I'm just going to jog your memory real quick about where we kind of left off and then we'll keep going. So what we established last class was if we create a plane that plots a person's income when they're healthy against their income when they're sick, then any dot within that space can depict what a particular insurance contract would look like. And so that dot will tell us how much money a person will get if they're sick or if they're healthy, and then we can impose indifference curves along that space and kind of compare different insurance contracts to see which contract would yield more utility for a customer. So the question I want to begin with today is, where in the IHIS space will insurance companies and consumers be happy to meet and do business? So the idea is we've got all of these possibilities for positions where you might place a dot or different contracts. And so what dots are going to be such that people would actually go for an insurance contract that's characterized by that dot's income combinations, and likewise an insurance company would be willing to offer that particular contract. Okay, so to understand this, you're definitely going to need your class packet today because I'm going to have you shade in some of the graphs that I've given you in the packet. So if you don't have that, I'm going to talk really slowly in the next 10 seconds so you can pull it out. So make sure you get that piece of paper. Okay, so effectively our strategy for answering this question is going to be that we are going to divide the graph into different quadrants and then consider what would happen in each quadrant in terms of whether or not in that particular quadrant we both have insurance companies happy to offer contracts there and customers being happy to purchase contracts there. Okay, so let's look at the graph really quickly. So the graph we're going to be using over and over again is going to be one that has a full insurance line. So that's the 45-degree line that shoots out from the origin. The graph is also going to have a big dot on it. That dot is going to coincide with the income levels a person would get if they don't have insurance. So ISU will be the income they get if they're uninsured and sick. IHU will be the income they get if they're uninsured and healthy. Okay, importantly, any person is going to have an expected income based on their probability of being sick and the different income levels they would get if they were sick and healthy and uninsured. So what we're going to do is we're just going to kind of not put a specific number on this, but just say every person has an expected income that coincides to what they would get if they were uninsured. So we're going to call this EIU, and we can plot that on the full insurance line, and then we're going to draw a line from the dot up to that expected income, and that's going to give us the person's zero profit line. Okay, so far we have three components on the graph. We have full insurance line, we have the dot, we have the zero profit line, and then the last important component is we're going to draw an indifference curve that intersects the dot. Okay, this is very important because it's going to represent something. Okay, an indifference curve consists of a whole bunch of different points where each of the points along the indifference curve is one that a person is indifferent between. So since this indifference curve intersects the uninsured dot, what that means is that anywhere that you might place your finger along that indifference curve, a contract that coincides with that placement of your finger is going to be a contract that a consumer would not prefer or unprefer, or whatever the word is, relative to being uninsured. Okay, so now here's where you need to whip out your piece of paper and start shading. So the first quadrant that we're going to consider is the part of the graph that resides above the person's full insurance line. So on your piece of paper, shade in the region that is northwest of the full insurance line. Okay, again, the question we're going to consider is, in this shaded region, could we place a dot somewhere in that region? And then that dot, which would coincide to an insurance contract, would be one that insurance companies would be happy to sell and consumers would be happy to buy. Okay, the first thing to note is no matter where you place a dot in that shaded region, the coordinates of that dot will be such that sick income is greater than healthy income. Okay, that means that there is risk in a person's life. So if you think back weeks ago, I don't remember what the date was for this lecture, so people are risk averse, so they don't like volatility in their income. So if they are offered an insurance contract that gives them more money when they're sick than when they're healthy, then they have the original problem that they started with, in that if one thing happens to their health, then it's going to lead to one shock to their bank account that's different than what would happen if they had a different kind of event in terms of their physical health. Okay, so what I'm going to argue here is that this whole shaded region is home to contracts that are over full. So this means that these contracts pay out more to consumers when they're sick than when they're healthy. And so it's kind of like, to get from the original uninsured dot into the shaded region, you'd have to go and run through the full insurance line. And the full insurance line is the home to all the contracts that wipe away all the risk and uncertainty from a person's life. You're going to have to bypass that line, go through it, and get back into the region of having risk or uncertainty. So theoretically, it is possible that you might have an insurance contract in this region, but it's going to be very unlikely that any insurance contract in this region will realistically materialize in the world, because it's one that's just like really weird. It's like an insurance contract where you have volatility in your income, and it's wonky volatility such that your income is like especially large when you get sick. So we're just going to rule out that whole region and say any contract that's offered where if you plot that contract and it falls in the shaded region, that's not really going to be a contract that's going to survive in the real world. Okay, so now let's move on to the next possible region. So we're going to have a new graph. It starts out blank, and now we are going to shade in the graph. So this is the next page of your notes. The part that is underneath the full insurance line, and it's also underneath the indifference curve that intersects the person's uninsured dot. Okay, again, we're going to ask ourselves the same question. The question is there any insurance contract such that when you plot that insurance contract and it falls within that region, that contract would be a contract that might actually exist in the real world? Okay, the first thing to note is that whole region is underneath the indifference curve that intersects the person's uninsured dot. That means no matter where you position a dot in the new shaded region, the indifference curve that intersects that new dot is going to be below the person's original indifference curve. That means they'd be happier without any insurance at all than they would be with a contract that was offered to them that was characterized by having income levels that sit in this new shaded region. Okay, so what this means is that this new shaded region is home to contracts that are less preferred to no insurance at all. So because this is home to contracts that are less preferred to no insurance at all, people would rather just not have insurance than purchase any contract that's offered within this region. Okay, let's consider another quadrant of the graph. So we're going to move down to the next graph, and now we're going to shade in the region of the graph that is underneath the full insurance line, but it is above the person's zero profit line. Okay, the important thing to note about this region is that it's above the zero profit line. So if you think back to last class, the zero profit line was kind of the pivot point for whether or not a person would be becoming richer or becoming poorer relative to their uninsured state. Likewise, it's also the pivot point for whether an insurance company is going to make a expected profit that's greater than zero or less than zero. Okay, importantly, the whole region above the zero profit line is in the unprofitable region for an insurance company. So any contract that is exchanged above the zero profit line is going to be one where the the consumer is becoming richer, but they're becoming richer at the expense of the insurance company, which is losing money, and they have an expected profit less than zero. So what this means for us is that no insurance company would ever be willing to offer an insurance contract in the region we have shaded now, because if they offered it and somebody bought it, then they'd be expected to lose money. So what this means is that this is home to unprofitable insurance contracts. So because of this, we would never have an insurance contract that's actually survives in the market if it resides somewhere in the shaded region. Okay, so far this is all bad news, because the whole point of this chapter was we were trying to construct a model where we embrace the fact that there's adverse selection, but we want to somehow avert a death spiral. And so far, we have no region of this graph that is such that an insurance contract could survive in the market if it was offered in the different regions that we've looked at. Okay, there's one last sliver of the graph that we haven't considered. So flip the page one more time, and we're going to shade in one final little wedge, and then consider whether or not an insurance contract could survive if it was characterized by income combinations that reside within this last region. Okay, so on your piece of paper, the region you now need to shade is a little wedge that is underneath the full insurance line. It is underneath the zero profit line, and it is above the indifference curve that intersects the person's uninsured dot. Okay, first thing to note, this little wedge that is shaded is above the person's indifference curve that intersects the uninsured dot. What that means is that if you place a dot anywhere within that wedge, if you drew an indifference curve through that new dot that sits in the wedge, then that indifference curve would be higher than the indifference curve that's printed on your piece of paper, which is kind of representing the happiness level that a person gets from being uninsured. So what this means is that a consumer would definitely like to buy a contract that's offered in this region, because if they bought a contract in this region, it would yield higher utility for them. Okay, the second thing that's important to note about this is that that little wedge sits underneath the zero profit line. Again, the zero profit line is the pivot point for when an insurance company is making expected profit greater than or less than zero. And what we learned last class is that all of the coordinates that are underneath the zero profit line are coordinates such that the insurance company would be expected to make a positive profit if they sold one of those contracts. So what this means for us is that an insurance company would definitely be willing and happy to offer a contract in this little wedge because they would be expected to make money. Okay, so to summarize, here within this little space, an insurance company could make a positive profit, and the consumer would have more utility than if they were uninsured. Again, we see this because any dot within this little region would reside on an indifference curve that is above the indifference curve that passes through the person's uninsured dot. Okay, we call this region the feasible contract wedge. Okay, what does the feasible contract wedge mean? It means exactly what it sounds like. So this is the wedge within the graph where if any insurance contract was offered within this wedge, it would be feasible for that insurance contract to survive in the market without the market running into a death spiral. And the reason those contracts, again, are feasible or have the ability to survive is because they both benefit the customer, and at the same time, they're also benefiting the insurance company. Okay, now that we have determined which contracts could feasibly exist, we need to define an equilibrium. Okay, let me give you a little bit of framework for thinking about equilibrium. The idea is the feasible contract wedge is this little wedge where anywhere you might have a dot within that wedge, a contract could survive. An equilibrium is different than survival. An equilibrium is a contract where if that contract is offered, then that contract could be exchanged in forever. Like, we would never deviate from that contract, and we'd reach kind of a standstill in the market where we wouldn't be jumping around from contract to contract within the wedge. So again, equilibrium is kind of like the ripples in the water have calmed down, and we're just kind of in a steady state where we have a particular contract that is mutually beneficial for the buyers and the sellers, and we're just happy to sit there forever. Okay, there's going to be three conditions that are necessary for a contract within the feasible contract wedge to be in equilibrium. So a contract, or specifically a set of contracts, is in equilibrium if, number one, all individuals select the contract in the equilibrium set that offers the most utility. Number two, no contract in the set earns negative profits for the firm offering it. And number three, there exists no contract or set of contracts outside of the equilibrium set that, if offered, would attract consumers and earn at least zero profit. Okay, I'm going to give you some examples of this so it's a little bit more clear, but to begin with, let me just kind of set up some assumptions here. So let's assume that there is no information asymmetry and a set of homogeneous consumers. Okay, what this means to begin with is no information asymmetry, so this is a little bit unrealistic, but to just start with, we're going to make this assumption. That is, we're going to assume both the buyers and the sellers of information have kind of equal information about a person's probability of getting sick. Again, unrealistic, but let's just start there and then we'll kind of, we can deviate from that in a minute. Okay, the second assumption is we're assuming a set of homogeneous consumers. Homogeneous means identical. So if consumers or people who are buying insurance are homogeneous, then what this means is that they all have the same probability of getting sick, P. They all have the same income if they get sick when they're uninsured, IS. They all have the same income if they stay healthy and they're uninsured, IH. And if everyone has the same income levels and probabilities of getting sick, then that also means everyone is going to have the same expected income. If they all have the same expected income and they all have the same original income combinations when they're uninsured, then this means everyone in this market is going to have identical zero profit lines. Okay, now let's consider different contracts. Okay, to begin with, let's consider contract triangle. This contract is positioned kind of smack dab in the middle of the feasible contract wedge. And what we want to ask ourselves is, okay, it's feasible for this contract to exist. Like, we wouldn't have a death spiral if this contract were offered. But the question for us, is this an equilibrium contract? Like, would the market be happy to offer this contract in perpetuity? Okay, again, there's three conditions for a contract to be in equilibrium. So the first thing we want to kind of check off is whether or not people effectively would prefer this contract to being uninsured. Okay, first, note that all customers prefer Triangle to being uninsured. Okay, the reason this is true is because if you draw an indifference curve through Triangle, it's going to be higher than the indifference curve that goes through Circle. The indifference curve that goes through Circle is the indifference curve that represents how happy you are when you have no insurance at all. So Triangle, in other words, would yield higher utility for a person than not having any insurance. Okay, so we can check kind of the first criteria for this being in equilibrium. Second thing is we need for this contract to at least generate an expected profit that's at minimum zero, but it could be above zero for the insurance company. Okay, contract triangle does generate an expected profit that's greater than or equal for the insurance company. Again, the reason we see this is because of the argument I made a couple minutes ago. Triangle is underneath the person's zero profit line. All the space that's below the zero profit line is a region where an insurance company is expected to make a profit that's greater than zero. Okay, the last condition for an equilibrium is effectively that there's no opportunity for a competing insurance company to come in and offer another contract within the wedge that would cause all the consumers to drop their Triangle policies and run over to the other contract that's offered. Because if that's a possibility, then clearly Triangle isn't in equilibrium, because when a new firm comes to town, everyone abandons Triangle, and if you're abandoning a particular contract, you're clearly not in an equilibrium. And so what we need to be true is if Triangle is going to be in equilibrium, then there can't be any opening or any opportunity for another insurance company to come in, offer a contract within the wedge that's different from Triangle that would steal all the customers away from Triangle. Okay, if that's true, then Triangle would be in equilibrium. But there's an opening for another insurance company to come into the market and steal all the customers, if we're thinking about Triangle. Okay, the way we can see this is, suppose another insurance company comes to town. They offer Contract Square. Contract Square is going to have an indifference curve that runs through it that's higher than the indifference curve that runs through Triangle. That means if all the customers in the market currently have Insurance Contract Triangle, and then they're offered Insurance Contract Square, well, they'd all drop Contract Triangle and go over to Contract Square because Contract Square would make them happier. Okay, so let's just consider Contract Square. Could Contract Square be an equilibrium? The same conditions have to be satisfied. So the first thing to note is that consumers prefer Square to being uninsured. The way we see this is because the indifference curve that would run through Square is going to be higher than the indifference curve that runs through the uninsured circle. Okay, the second thing we can note is that Contract Square generates an expected profit that's greater than or equal to 0 for the insurance company. Again, the way we see this is because Square is underneath the 0 profit line. But the last condition is not satisfied. So Contract Square would be an equilibrium if there's no opportunity for another competitor to come to town and steal all the customers away from Square. But there's still an opening for another insurance company to come in and steal all the customers. Okay, the opening is somewhere in the little sliver of space that exists between Square and the 0 profit line. So as long as there's room for another contract to wiggle in that little space between the contract and the 0 profit line, then consumers would actually go for that new contract that's in that little sliver of space, because that little sliver of space gets them further out to the northeast, and in other words, it would give them higher utility. Okay, we can kind of keep on making these arguments in an iterative fashion, and what we see is that consumers keep on dropping policies and going for competing firms' contracts as long as those new contracts get them closer and closer kind of to the boundary of the 0 profit line. So now let's just reach the boundary. Let's consider contract Sun or Star, whatever it looks like on the screen, and let's consider whether or not that contract would be an equilibrium. Okay, the first thing to note is that consumers prefer Star or Sun to being uninsured. The way we see this again is because if you draw an indifference curve through the Sun, then that indifference curve would be higher than the indifference curve that runs through the uninsured dot. The second thing is that Contract Sun generates an expected profit that is greater than or equal to 0 for the insurance company. Specifically, it's equal to 0 because it sits on the 0 profit line, but all that's required is that the expected profit be greater than or equal to 0. So in other words, the insurance company isn't expected to make a loss if they offer this contract, so they should be willing to offer this contract. Okay, this Contract Sun is going to satisfy the equilibrium conditions because on top of it being preferred by customers to being uninsured, and on top of it not being expected to cause the insurance company to make a loss, there's also no opening for another insurance company to come in and steal all the customers if all the customers are currently buying Contract Sun. Okay, so the final takeaway is that only when insurance is full and fair are the equilibrium conditions satisfied. Okay, let me say that one more time. Only when insurance is both full and it is fair are the equilibrium conditions satisfied. Okay, make sure that this registers with the graph. So Contract Sun is the only contract that exists in equilibrium. Contract Sun is full. How do we see this? It sits on the full insurance line. Contract Sun is also fair. How do we see this? It sits on the 0 profit line. So only when those two things are true will the equilibrium conditions be satisfied. In other words, will we get an insurance market that both averts a death spiral and it's happy to sit in this particular location forever without kind of jostling around and having other contracts kind of picking up consumers. Okay, this is the end of part 2 of chapter 9. If you have any questions about this, again, reach out during the next 10 minutes, and then after that, I'm going to give you a problem where you can practice calculating what an equilibrium contract would look like for a particular set of consumers who are homogeneous. So I'll talk to you after 10 minutes. All right, for the exercise today, what I would like you to do is I would like you to think of a set of homogeneous customers or consumers. Let's continue to assume that there's no information asymmetry. Again, we'll kind of relax both of those things next class to make the model more realistic, but let's just start out with that. And specifically what I want you to do is I want you to consider a set of homogeneous consumers with a sick income when they're uninsured of $25,000, a healthy income when they're uninsured of $30,000, and then they're homogeneous, so all of the people are also going to have a 40% probability of getting sick, so their P is going to equal 0.4. Okay, the question that I would like you to answer is what would be the equilibrium insurance contract for these set of consumers in terms of the income that it would yield if these consumers either get sick or stay healthy. So to answer this question, it's going to be helpful for you to first of all plot out the same graph that we've been looking at. So on your own piece of paper, plot on the horizontal axis income when you're healthy, on the vertical axis income when you're sick, draw the full insurance line, draw the dot that corresponds to these people's income combination when they're uninsured. Then calculate each of these people's expected income. Plot the expected income on the full insurance line. Draw a line that goes from the uninsured dot to the expected income. That will be each of these people's zero profit line. Then you can also draw an indifference curve that intersects the uninsured income combination. And then think about, based on what we've talked about within that picture that you've created, where the equilibrium contract would be. And then I want you to give me the coordinates of that equilibrium contract. So your answer that you turn in should be of the form, the equilibrium contract will be such that IS equals a number, fill in the number, and IH equals a number and fill in the number. Once you have that done, you are free for the rest of the day. Again, I'm just going to reiterate, make sure you're reading the textbook for this chapter because it's a difficult chapter. So extra reading will definitely help. And other than that, hope you all are hanging in there with the rest of your classes, and I'll talk to you next class.